Hi everyone, my name is Vector. Today I'm going to present our work, Clairvoyance, Inferring Blocklist Use on the Internet. This is a joint work between UC San Diego and UIUC. So what is blocklist? A blocklist is a list of indicators that are known sources of malicious activities, like IP addresses or domains of command control servers, botnets, or senders of spam emails. They are widely used in all kinds of security products like firewall or SIEM to directly block traffic or generate security alerts for people to investigate. There are many public and commercial providers offering this data. Here I give some examples of public and commercial providers. And this is a thriving industry with market size predicted to surpass $13 billion in 2025. So with this many providers and all the attentions, there's one particular question that there's little people have looked into before in our community, which is how people are actually using this data. This is important because it's not only help us understand adoption of the data, but also give us a sense of the potential impact this data can have on the internet. And this is a problem this paper tried to look into. There are many ways people can use blocklist. So in this study, we focus on one particular use case, IP-based traffic blocking using IP blocklists, where people proactively block incoming traffic if the source IP matches the data in a blocklist. And this blocking is on the network layer. In this paper, we propose, implement, and test a technique for inferring the deployment of such blocking behavior, and we conduct a pilot study to measure the popularity of such use cases. So first, how do we infer this blocking in the first place? We do not have access to IPs on blacklist. Either do we have access to the target hosts we want to measure. So how do we, from a third measurement machine, measure if a target host blocks an IP in a block list? So that requires side channel. So here we use an old technique, IPID side channel. IPID is a 16-bit field in the IP packet header. It is used in IP packet fragmentation and reassembly. And as you can see, they need to be unique throughout a communication. And many old operating systems use a shared monotonically increasing counter to implement this feature. And this side channel gave us opportunity to measure the blocking. So for target host, we first send a probe packet to get the first IP ID, let's say 3. And this will trigger the IP ID to +1, now it's 4. And then we send another packet, but we spoof the source IP address to be an IP on a block list. And if there is a blocking in place, the target host will not get this packet and the IP ID will not change. So if we probe again, we will see the IP ID now equals to 4, just +1. On the contrary, if there is no blocking in place, then on the second stage, the target host will get our spoofed packets, triggering the IP ID to further +1. So then our later probe will get the IP ID equals to 5. So now there's a gap. So the difference between these two scenarios will help us to distinguish that the target host is blocking the IP on the block list or not. And this is how this technique works on a high level. Of course, to make it work in real world, we need to take into consideration all kinds of noises. I will not go into the implementation details, and you can find that in our paper. And with the technique set, you can see that this will only work on certain type of hosts. We refer to hosts that are suitable for this technique as reflectors. And there are 4 criteria. Shared IP/IT counter, which is the side channel, low traffic, no ingress filtering, and no stateful firewall. And to test if a reflector is blocking traffic based on a particular IP block list, we sample IP from that list to test. And the sampling also need to meet certain criteria. I will not go into these criteria in detail, but all these criteria are here to ensure we will have as little noise as possible during our measurement. So with that said, now we'll present our evaluation. We evaluate our technique with a pilot study where we scan online hosts in the United States to find suitable reflectors. And then we run a quick test over 100 IP blacklists to choose the most blocked ones for our in-depth pilot study. In the end, we select over 200,000 reflectors and 9 blocklists for our pilot study. In each blocklist, we sample 25 IPs and test these IPs against all the reflectors. We repeat this experiment 3 times and conclude a reflector is yielding a blocklist only if it blocks all IPs we sampled from that list. So here is an overview of our measurement result. In total, we discover 1.9% over 4,000 reflectors are using a particular blocklist. And there are another 21% that block some of the IP we sampled, but not all of them. The rest do not show any blocking behavior. So looking into that 1.9%, here's a breakdown of all the reflectors that are using each of the block list. And as you can see, the most used block lists are spam house drop and spam house E drop. We also look into the pairwise intersection and organization breakdown of all the reflectors that uses certain block lists. And there's some interesting results you can find in our paper. Beside that 1.9%, there's still a significant percent of reflectors that block part of the IPs we sampled in each block list, but not all, as we can see from the graph. This suggests that many reflectors deploy some blocking policies that overlap with those block lists we choose. In conclusion, we proposed, implemented, and tested a technique for inferring the deployment of IP-based traffic blocking using block lists. Our pilot study covered over 200,000 US hosts, identified block list usage in 1.9% of these hosts, and found blocking behavior in roughly 1/4 of all hosts. And although this technique only works in certain hosts, it actually can be extended to work on a broader set of machines with the latest operating system, using advanced IPID inference technique demonstrated by a recent Unix security paper. And the future study should continue looking at this problem and get a clear picture of the block list usage on the internet. Thank you very much.